Hello, and welcome to the Raised Beaches podcast, a podcast about paleoclimate and global change. I'm Dr. Evan James Gowan, but you can call me Evan. This is episode 3 of the Raised Beaches podcast, and I'm recording this on October 30th, 2024. Today's podcast, I'll be talking about the hurricanes that have tragically hit southeastern United States. A paper about sea level rise doubling in the rate of sea level rise doubling in the past 30 years, and a global coastline data set. In this episode's deep dive, I'll be discussing about proxy records, and I will talk about 3 papers. One will be on methane fluxes in Beringia. Another will be on paleo sea level changes in northwestern Canada. And another one will be on Phanerozoic climate changes. So Phanerozoic covers most of the past 500 million years. So that is a very interesting paper. So it's October, very late October, and Japan, the autumn is coming very slowly. So today it was a bit cooler, but last weekend I went to this town called Misato, which is located in central Kyushu, which is the island that I live on. And you driving around there, none of the trees have started to change color, which is quite unusual, I think. And it's been because the summer is so hot, it's basically delayed the start of the autumn. And they are really not expecting the colors of the trees to change to their autumn reds and yellows until well into November. So yeah, it's just another sign that the climate is changing here in Japan, that the autumn is getting delayed. And another thing that I did in October, so in Japan, there's a long weekend in mid October called Sports Day, and because it's been so hot, my wife and I said, well, we better hit the beach. It's nothing I like better than the beach. And we went to Nagasaki in close to this town called Sasebo. And of course, when I go to the beach, I want to explore the geology a bit. And so the rocks at the beach we're at are Miocene in age. And sort of the earlier part of the Miocene, so around 18 to 22 million years old. And, I picked up one of the rocks. So if you're watching the video version of this podcast, you'll be able to see my rock. And anyway, so this rock, the bottom part of it is sort of a medium grain-sized sandstone, and on top it's very abrupt change to this very shell-rich. Maybe you could call it a coquina, because it's a large part of it is shell fossils, but it's still got the same kind of sand in it. And walking along this beach, you could see this transition in the bedrock from this medium-sized sand to the shelly layer, and the abruptness of it, and the fact that the matrix is, or there's still this sand within the shell layer. It makes me think it's probably a storm later, and there was also kind of this pyroclastic flow material in the rocks as well. So makes me suspect that there was a volcano nearby. And yeah, I looked up the geology of this area near Sasebo, and basically, it was a coastal area that was uplifting, probably, and this was during the period of time when the Sea of Japan was starting to form. So that was pretty interesting to see. Another thing we did in Sasebo, we took this cruise around these islands. So there's these little islands everywhere because the landscape is basically a flooded river valley area because which formed when sea level was lower. And you look around these islands and you can see there's like these terrace levels that are above the high tide level. And it's a sign that at some point the sea level was a bit higher than present. And looking at the museum that they had there, they suggested this was during the Holocene, mid-Holocene, so like 6,000 to 7,000 years ago. So sea level dropped after that point in time. And this area, I don't think is uplifting, so I don't think tectonics are really responsible for that relative sea level change. So I've talked about this in the previous episodes about ocean siphoning, and this is probably a result of that there's been a bit of a sea level drop due to the water going back towards where the northern hemisphere ice sheets used to be. So the really big weather story that's happened in the past month are that there were two major hurricanes that have hit the southeastern United States, Hurricane Helene and Hurricane Milton. And this is being driven by the fact that the ocean surface water temperatures in the Gulf of Mexico are very, very hot. So this has allowed these hurricanes to develop very quickly and also to get very powerful. As an example, Hurricane Milton explosively intensified and the central pressure went below 900 hectopascals. So that just the pressure can give you an idea of how powerful the storm is. And in the Pacific, we have typhoons, which are the similar kind of storms. And it's not so uncommon to have the pressure for typhoons to go around 900 hectopascals, but in the Atlantic, it's pretty rare. So Hurricane Milton is achieving a central pressure below 900 hectopascals is quite remarkable. And it was a very powerful storm, and I really sympathize for all those who are affected by these disasters. And it is a reminder that areas in that region are very vulnerable to these hurricanes, which seem to be getting stronger as time has gone on. And the likelihood of these kinds of disasters is going to increase because the surface ocean temperatures are increasing. And one place that was affected that's relevant to paleoclimate was the National Centers for Environmental Information, which is basically a center within the National Oceanic and Atmospheric Administration in the United States, which stores data related to climate and of course paleoclimate as well. So the description, the National Centers for Environmental Information, is also known as NCEI. And NCEI maintains one of the most significant archives on Earth with comprehensive oceanic, atmospheric, and geophysical data. We archive over 229 terabytes of data each month from over 130 observing platforms. And so this center is located in North Carolina, which was affected by Hurricane Helene. And, of course, I really feel bad for all the people that were affected by the hurricane. And the center was down for several weeks, and they worked very hard to get this back up, because the information stored on these servers is used for weather forecasting, for instance. And this is not the first time this center's gone down. I remember during my PhD, the NCEI went down due to the government shutdown, and of course that's a man-made problem. And we have to think that these government organizations that hold this valuable climate data are vulnerable to political changes. So we all know that there's this big election next month, and it's my hope that the results will be favorable, so that the NCEI will not be vulnerable to shutdown. And when the government shutdown happened I think it was in 2013, the Internet Archive was backing up a lot of this data, but the Internet Archive itself in the past month was hacked, and it just goes to show that there are actors out there who do not like the fact that information in general is available. So it's not a great time right now climatic information is vulnerable to meddling from governments who don't like what it says. The next bit of big news that happened in October was the release of a paper by Hamilton et al., and this paper was called the Rate of Global Sea Level Rise Doubling During the Past 3 Decades, and it was published on October 17th in the journal Communications, Earth and Environment. And what this paper did is that they looked at the satellite-based measurements of global average sea level. And I talked about this in episode 2. And the authors of this paper are kind of responsible for maintaining that time series. And coincidentally enough, there's been 30 years of measurements, and that's usually kind of a baseline in climatic data to sort of be able to think about averages and like as a baseline. And basically what they've done is they've calculated whether the rate of sea level rise in the past 30 years, which is around 10 centimeters, whether that rate is changing. So if it was just a linear change, you would just see a flat line. And in some ways, you look at the data, and it does kind of look linear, but I think the past 5 to 10 years, the rate has been increasing. That's something you can see in the annual measurements. And anyway, the rate around 1992, they said, was about 2.1 millimeters per year, and now it's 4.5 millimeters per year. So the increase in sea level is being driven mainly by 2 things, and that's the ocean water is warming up, and the second thing is that glaciers are melting. And if you look at the time series, it's not smooth. There's like up peaks and troughs. And I remember during my PhD, there was a big trough, and that was related to a large flood event that happened in Australia. So there was so much water in this flood event that came out of the ocean that it caused global average sea level to fall for a while. But, it's a flood event, so that water eventually went back into the ocean. And anyway, this paper is kind of just an update, and most people who are involved in investigating sea level changes are aware that the sea level rise rate is increasing. So it's kind of an incremental paper, but nevertheless an important paper to communicate the fact that sea level is accelerating. And in the end of the paper, they sort of extrapolated what they think the sea level rise will be by 2050, and they estimated that there'll probably be about 20 centimeters of sea level rise in the next 25 years, which, that's like 3 times higher than the amount of sea level rise in the past 30 years or so. Anyway. The last thing in this introduction I'm going to talk about is the global coastline data set. And this is called the Global Self-Consistent Hierarchical High-Resolution Geography Database, or GSHHG. Yeah, that's a bit of a mouthful, even for me. And this data set was originally created in the early 90s by Paul Wessel and Walter H.F. Smith. And Paul Wessel and also Walter Smith are most famous for creating the generic mapping tools, which is a software tool set that allows you to plot and analyze geospatial data. And I'm not exaggerating when I say Paul Wessel is one of the most influential geophysicists in the world. And unfortunately, he passed away earlier this year. But his influence on geoscience has been immense. And anyway, the GSHHG consists of three sort of data sets. One is the world vector shorelines, the C, which is the shoreline data, the CIA World Data Bank 2, which contains the lakes, the rivers, and the political boundaries. And they also use the atlas for the cryosphere for Antarctica. And anyway, the last update of the GSHHG was in 2017. And I've found this to be a bit problematic for my work. So last year I published a paper on paleo sea level changes in Greenland. And one of the things that I was doing was plotting up where the data were located on a map. And all I had was this GSHHG on the map, which was showing the outlines of the coastline of Greenland. And what was happening is that these data points were not showing up where the shoreline was. They were being plotted way out in the ocean. And I'm like, this doesn't make any sense. And the person who collected this data, Sven Funder, I emailed him. It's like, this doesn't work out. And he's like, we measured where these data were with a differential GPS. The location should be correct within a few centimeters. And so I was scratching my head, and then I went further and plotted the topography data set. And so the topography, the data points were in the correct location. So the problem was the coastlines. And if you look at where the coastlines are versus where the topography is, and in some places it's off by 40 kilometers, and so yeah. Anyway, I submitted a bug report, and Paul Wessel responded, and he said, "Well, yeah, we know that the coastline is problematic. But I don't have time to fix it right now." And this is very problematic because lots of things use the GSHHG in their products. A good example is Google Earth. So if you zoom into northern Greenland, you'll see that these chunks of ice that is where the island should be. But that's since the coastlines are in the wrong place, the islands don't show up. It shows the ocean, which is covered in ice. So you'll see that the satellite imagery is sometimes cut off because the coastline is in the wrong spot. So this is a consequence of these errors in the GSHHG, and it can be very visible what happens if you're relying this when you are georeferencing your database or your data sets. And the way that I fix this problem, at least for my Greenland paper, was that I created a shoreline by basically taking the topography data set and drawing a contour where the elevation was 0. And for Greenland, that works okay, I guess. But you could not generate a coastline everywhere using this technique, and this is because in some places things are very flat near sea level, and a good example is in the Jiangsu province in China. If you look at the topography database, since the land is so flat, you can see artifacts in the topography data set where it fluctuates between within a few meters of sea level. So if you were using a contour of the 0 elevation mark, the coastline would not be in the correct location. And this is really something that needs to be done manually. And of course, you have to think that the coastline itself is not necessarily going to be constant, especially since we have sea level rise. And for someone like me who looks at broader scale things, this may be not such an issue, but ultimately this global data set of coastlines is probably used by a large proportion of people who make maps, and this it's not necessarily accurate, and most of this data were derived from topography maps that were drawn, decades ago, and obviously this should be updated, but nobody's doing it. And you'd think, well, somebody should be maintaining a data set of coastlines, because that is important, especially with lakes and rivers. They change through time. But yeah, nobody, as far as I know, nobody's doing that, and I think that's kind of crazy. I think somebody should be maintaining this data set, and I hope that this does happen at some point, but that seems like a UN sort of thing that should be done. It should be done by the United Nations or some international consortium. But I'm just one person who has very little resources. So I guess I'm not going to be the one who does it. I just don't rely on these coastlines to be accurate. Is all I'm going to say, especially in places that are sparsely populated like Greenland. So I have seen people use Google Earth to georeference things, and that's a very bad idea. Like they use this coastline data set to georeference their satellite data. So yeah, don't be careful out there and make sure you think about your data. That's my message. So that's it for the introduction.